A very good day to everyone. I'm going to give presentations about our assignments, Advanced Robotics, with a title of Safety Structures of a Robot Using Combining Energy and Power-Based Safety Metrics in Controller Design for Domestic Robots. For introductions part, sophistications of the robot brains and their ability to perceive danger depends on the level of ability for his robots to apply the laws. The development of domestic robots have accelerated in the robotics field that can operate as assistants in home or office activities. Domestic robots also require meaningful norms to evaluate their safety before they can be successfully deployed around human users. There are different safety metrics that deal with collisions injuries, and they consider accelerations, force, energy, or power as a main parameter for the safety analysis. A compliant joint CZ is a flexible connector that can provide limited displacement between two rigid parts through materials deformations. Each matrix, which is computed in the neighborhood of a configurations of interest, is firstly split into two submetrics containing the coefficients relative to either linear or angular displacement. So everyone, these are the views of materials. There are actuator motors, stepper motors, piezo motors, air muscles, electroactive polymers, and elastic nanotubes. These are the components that must be in each robot. For this slide, for technical principle, based on the diagram, by design, the pacemaker timing circuits detects and prevent fast stimuli that pose the risk if inducing fibrillations. This is an example of the first law preventing harm by inactions of the pacemaker. This introduces a new hazard input signals that mimic a normal IECG depolarization signals and spoof the sensing circuitry. Additional digital circuitries was added to detect false IECG signals, disable sensing, and continue asynchronous pacing in the presence of interference. Pacemakers so equipped can be programmed to detect that its battery is approaching depletions and alter its operations to reduce power consumptions and also signals the low power conditions. For technical principle, slide 2. The most common safety metric in domestic robotics is the head injury criteria, which is also used in biomechanics study and accidents research. Human biomechanics data defined in the Wayne State concussions tolerance curve is the basis of this safety matrix, and it is computed by using measured accelerations of a human head due to an impact. So it comes with equations for head injury criteria, where AT is the head accelerations measured in the functions of G, and T is the measurement duration, which is often taken as 15 milliseconds to investigate head concussions. From these physical interpretable equations, possible injury to a human head is identified to be proportional to the rate of kinetic energy transferred during impact. This rate of energy transfer was previously suggested as an injury measured of constrained organs in the viscous criterion safety matrix. For technical principles, slide 3. This control design approach grants as an insightful view of the system, simplifies tuning, and allows an overall stability analysis by using the total energy as a Lyapunov functions. The resulting control system is a conventional PD controller that guarantees closed-loop stability for any positive gains, with the proportional term representing the spring and the derivative term representing the damper. In addition to its passive nature and the compliance it adds in the system, this impedance controller with unmodified driving point inertia can be more human-friendly by incorporating a safety metric in its design to minimize possible injuries. For these technical principles, slide 4 is talk about severity levels. SAEJIJ1739 is a table of a range of severity levels. Is tidy in its grading of severity into 10 levels. However, the descriptions for each level refers to general terms such as safety, government regulations, and customer satisfactions, but does not directly use terminology that relates to human injury and are open to broad interpretations by designers. The insurance industry and their legal counsel routinely engage professional engineers to investigate laws and then to perform as professional expert witness regarding their findings. Engineers thus retained as expert witness apply the laws of physics to aid in determining what actually happened and assist legal counsels in determining culpability. This process is generally known as forensics engineering. When it comes to evaluating systems to determine if a design defect was present, failure mode and effect analysis can be extremely useful. The effect is then gauged for the severity of the effects. The effects and then their risks then used to provide feedback to the design team. This is the element of sustainability. We must regular test sprints to ensure the constants. First, we must focus on what we are doing, and second, fast identifications of safety issues and fast accommodations of user feedback. Third, we must test under realistic conditions and direct technical feedbacks from customers, engineers, and those consumers of using the products. Thank you everyone for listening to my e-presentations. Thank you very much. Have a nice day.